zeroth level. It doesn't make a new folder for you.
Just puts it
Right. So it can't fit all those files on the desktop. It's not. I think there's like a size limitation for what you can put on the desktop, and that's the issue. Is that guess what? You can't fit thousands of files on your desktop.
we'll make a new folder.
Who would have known?
Just in case this thing happens.
Yeah, definitely keep all this stuff in a folder.
It's cool.
Don't let it go. It'll be a lot better right now because we're using just Verilog. But when you use schematics, every schematic's 30 or 40 things. Okay, so we come up to this screen. And this is where you would choose, just like you did before, you would choose your board and everything else. I honestly forget what the board number is that you're supposed to use. Yeah, I'm going to assume that it's this. This seems about right to me. Actually, yeah, I'm going to assume that it's this. Honestly, it doesn't matter until you put it on the board. And at that point, you can change stuff anyways, so.
What were you switching?
What the settings should be for the device properties.
What do you guys have in this?
If it saves all the values that we would use for our last project, it should be fine.
Okay. I think I'm just going to do this one last time.
Are you sign up for this?
No.
Okay. How much XC?
I'm going to be up late tonight then.
Just finish. Alright, then change everything.
One thing to make sure of is that your preferred language is Verilog.
I hope
Preferred
so.
language.
Okay.
Preferred language is Verilog.
Good one.
What does his say?
Oh no, it was just a device.
Okay. That's fine. It won't matter tonight anyways. But yeah, so this screen doesn't matter too much unless you're going to put it on a board.
We can always change it.
Exactly. So we're going to click next to this add new and existing sources. You can put in existing sources if you want. Adding new sources right now is kind of stupid. Let me know when you get to this point.
Okay.
Okay? Okay?
Okay, thanks, man.
Okay.
It's not 2K.
I know, but you guys
Keep going, Dave.
So, so the first thing we're going to do is add an adder. Now there is an addition sign in Verilog, but you can't use it because it doesn't give you carryout.
Oh.
Yeah. So you need carryout in this case. So what we're going to do is we're going to make a new source. And then go to Verilog module. And we're going to call this guy adder1b. And now you get to this screen where you get inputs and outputs. This is where we're going to add in what the inputs and outputs to our thing is going to be. So for port name, we're going to say there's going to be an input A, input B, output C or R, and you have to change this to output here, and then CO. Yes, CN would be good. Good idea. And then we're going to make that an input then. Yep. Carry-in is always important.
So we have 5 total?
Yep. 3 inputs, 2 outputs.
Cool.
And just for reference, an in-out is something that comes in and goes out. It's the same wire. There's very few times you need to use it. I think I remember one time we used it in digital. That's it.
That's cool.
Yep. And then finish. And you will get your Verilog code, along with an annoying design summary that tells you nothing.
Hey.
Okay. Now, this guy here is, and this is your general setup for how you have a piece of Verilog code. You're going to have the big comment that tells you nothing, the time scale at the top, just like you saw in your test benches, and then your module. Your module is kind of like a class, or think of a mod. So this is what I was going to tell you guys earlier. The thing to keep in mind about Verilog is that it describes circuits. It doesn't describe programs, it describes circuits. So when you're building these and you're reasoning about a Verilog program, think about what the circuit looks like. Don't think about what it actually, or what the program is. Okay, so, so like a module is going to be like a block in a block diagram, you know, and then we can zoom in and inside of it will be the code that we're actually working with. So if we're here, now, can anyone tell me what is the logic for carry out?
If A is 1 and B is 1 and you add them together, it moves over, combine, or it adds up, carries over to another spot. But if you're stuck to one byte placeholder, the carry out lets you know what's the byte in there.
I guess I'm asking what, so think about this like a circuit, okay? If you have our inputs, we need to set the outputs to something. What is carry out? Like, what is it logically? A and B, or
carry
A.
in and A, carry in and B.
right,
All those work.
or, yep, that actually will work. So, in order to get that, we're going to do carry out first just because that's simpler. So what we do is we do carry out equals, just like you would in a programming language, A, or parentheses, A and B, 1 ampersand, because this is a bitwise. We're working with bits here, we're not working with numbers. Or A and carry in, or B and carry in. Semicolons at the end, I believe. Let me check real fast.
Does spacing ever matter?
No, this is not Python.
Okay.
Python's the only language you'll ever see like that, I promise. Okay, yeah.
A carry and then B carry.
Does carry out make sense? How it's set up? This is a simple program. A 1-bit adder is really simple to write. Now, what's result going to look like?
It's only 1 if only one of them is 1.
Right.
Or all 3 are 1.
Or all 3 are 1. Right. So we start writing that out, and we have A and. Now, what do you guys think is not? Is the not thing?
Exclamation mark? Or is
You
it-
would think so.
It's the
Tilde?
It's the tilde. It's the tilde. We don't know why, it just is. Tilde is up top left.
Haha.
Yep. Okay, so I'm going to do this. Okay, so we've got our 1-bit adder, right? Now we want to test it. Let's test it just to make sure it works. You never know these things, especially with Xilinx. So what we do is we go to new source, again, Verilog test fixture, and put in your name. I always do test underscore the name of what I'm testing. It's a personal preference.
Test bench.
And then make sure that you select the one that you're testing. At this point, you can't test any, or you can't select anything else. And one thing to make sure is up here, make sure that you're clicking on simulate. I like to do model sim.
You mean simulation?
Yeah, make sure simulation and not
It's also as follows.
They're like
Go
a
on
test.
source.
That one.
Bench.
Go up.
Where
Text
you
fixture.
should- Yeah.
What do I call it?
Test.
Underscore I.
Test.
Underscore I.
Okay. So now, this guy's. So the test fixture is going to be exactly the same as what we did before. So we'll go ahead and just put in a few sample inputs, just to make sure that things are working.
What are you writing there, Dave?
I'm just this is in the test fixture or the test bench.
Yeah.
I'm just putting in random things,
Okay.
just to make sure that it works. This is exactly what you did earlier, so there's not really a huge deal if you don't do exactly what I'm doing.
Okay.
And